Preparing for a SRE at Grafana interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define and implement an SLO for a Grafana Cloud service? I would begin with the user journey, such as successfully loading a dashboard or querying metrics. For an SLI, I might measure successful requests divided by valid requests, excluding client cancellations. I would choose a target like 99.9% over 30 days, validate that it reflects customer expectations, and publish it transparently. The resulting error budget guides releases. Teams can move quickly while budget remains, but prioritize reliability work when it is exhausted. While answering, distinguish SLIs, SLOs, and SLAs. Choose user-centered indicators, define targets and windows, explain error budgets, and connect violations to release and operational decisions. Question 2. What is the difference between monitoring and observability, and how would you apply both at Grafana? Monitoring tells me whether known conditions are healthy. Observability helps me investigate unknown failure modes. I would monitor request rate, errors, latency, saturation, and slow status with actionable alerts. For investigation, I would correlate metrics, structured logs, traces, and profiles using consistent service and trace identifiers. Grafana dashboards can provide the shared view, while careful label design prevents cardinality and cost from overwhelming the system. Make sure to cover predefined health checks versus exploratory investigation, metrics, logs, traces, profiles, high cardinality dimensions, and how correlation reduces mean time to resolution. Question 3. How would you design an alerting strategy that avoids alert fatigue? I alert on user impact rather than every internal fluctuation. For example, an SLO burn rate alert can detect both fast incidents and slower degradation without requiring dozens of threshold rules. Each alert needs an owner, severity, clear description, dashboard link, and runbook. I route urgent pages only when immediate action is required, while tickets handle non-urgent work. After incidents, I review alert quality and remove alerts that do not change behavior. In your answer, discuss symptom-based alerts, slow burn rates, severity, ownership, deduplication, inhibition, runbooks, notification routing, and regular reviews of noisy or unactionable alerts. Question 4. How would you investigate a sudden increase in API latency? First, I would confirm whether latency affects all regions, endpoints, and customers, then compare P50, P95, and P99 rather than relying on averages. I would inspect recent deployments, traffic changes, resource saturation, dependency latency, database behavior, and trace spans. If CPU is normal but profiles show lock contention, I would test that hypothesis with targeted rollback or mitigation. I would communicate impact continuously and verify recovery through the original SLI. Be sure to mention confirming scope, checking recent changes, comparing percentiles, examining saturation and dependencies, using traces and profiles, forming hypotheses, and validating remediation with customer-facing metrics. Question 5. What makes a good production readiness review for a new Grafana service? A production readiness review should prove that the service can be operated, not merely deployed. I expect documented architecture, dependencies, ownership, capacity assumptions, SLOs, dashboards, actionable alerts, and a tested rollback. I also verify security controls, backup and recovery objectives, failure modes, and escalation paths. For a Grafana service, I would include telemetry cost and cardinality limits. Any unresolved risk should have an owner, deadline, and explicit launch decision. Focus on architecture, dependencies, capacity, SLOs, dashboards, alerts, runbooks, rollback, security, disaster recovery, ownership, and evidence from load or failure testing before launch. Question 6. How would you handle a major incident affecting Grafana Cloud customers? I would establish an incident commander quickly, define the customer impact, and assign leads for mitigation, investigation, communications, and documentation. I would prefer a reversible mitigation, such as disabling a feature or shifting traffic, while preserving evidence. Status updates should state impact, timeline, and next action without speculation. After recovery, I would verify slow and regional health, then run a blameless review that produces prioritized, owned prevention work. Explain incident command, customer impact assessment, roles, communication cadence, mitigation first, evidence preservation, status updates, escalation, recovery validation, and a blameless postmortem with measurable actions. Question 7. How would you build a capacity plan for a multi-tenant observability platform? I would model each workload separately. Samples or logs ingested, query concurrency, retention, cardinality, and dashboard refresh behavior. Then I would map those demands to CPU, memory, network, storage IOPS, and object store growth, keeping explicit headroom for failures and bursts. Tenant quotas and fair scheduling protect noisy neighbors. I would validate forecasts against real growth, load test representative workloads, and review capacity regularly because observability usage can change rapidly. Cover workload modeling, ingestion and query rates, cardinality, storage growth, resource headroom, tenant isolation, autoscaling, quotas, cost, regional failure scenarios, and continuous forecast validation. Question 8. What is a multi-window, multi-burn rate alert, and why is it useful? A burn rate describes how quickly a service consumes its error budget relative to the allowed rate. I might page when a short window shows rapid consumption and a longer window confirms sustained impact. Requiring both reduces alerts caused by brief noise while still catching serious outages quickly. Thresholds depend on the slow and response objectives, but the alert must always represent meaningful user harm, not an arbitrary infrastructure metric. Explain error budget consumption, fast and slow windows, severity differences, false positive reduction, threshold selection, and why burn rate alerts should remain tied to a meaningful slow. Question 9. How would you use Kubernetes for reliable deployment of an observability component? I would package the component with explicit resource requests, safe limits, readiness checks that reflect dependency availability, and liveness checks that detect unrecoverable hangs. I would spread replicas across zones, configure a pod disruption budget, and use a controlled rolling update with rollback criteria. Stateful data needs deliberate storage and recovery design rather than assuming pods are durable. I would also monitor deployment health and validate that probes do not amplify an outage. Discuss readiness and liveness probes, resource requests and limits, pod disruption budgets, topology spread, autoscaling, rolling updates, persistent data, security context, and operational rollback. Question 10. How would you troubleshoot high-cardinality metrics in a Grafana-based monitoring system? I would identify which metric and label combination is creating the series explosion, then inspect growth over time and the teams producing it. Request IDs, user IDs, and unrestricted URLs are common problems because they are effectively unbounded. I would remove or aggregate those dimensions at instrumentation or ingestion, preserve detail in logs or traces, and establish per-tenant limits. The goal is not simply fewer labels, it is useful, affordable investigation data. Mention identifying explosive labels, measuring series growth, distinguishing useful dimensions from unbounded values, applying relabeling or aggregation, setting limits, and balancing diagnostic value against storage and query cost. Question 11. Explain how you would design disaster recovery for a critical Grafana Cloud dependency. I would start by agreeing on RTO and RPO with stakeholders, then classify data by durability and recovery importance. The design could combine replicated metadata, durable object storage, automated backups, and a tested regional failover path. I would document dependencies and define degraded behavior when a non-critical system is unavailable. Recovery is credible only after regular exercises measure actual RTO and RPO, expose gaps, and update runbooks and automation. Cover RTO, RPO, dependency mapping, backups, replication, regional failover, automation, data consistency, degraded operation, recovery testing, and customer communication during restoration. Question 12. What reliability risks arise when operating a distributed metrics or logs ingestion pipeline? Ingestion pipelines commonly fail through overload, queue buildup, dependency outages, or retry storms. I would use bounded queues, exponential backoff with jitter, durable buffering where justified, and explicit backpressure. I would define duplicate and ordering semantics, isolate tenants, and shed low-value work before the entire system collapses. Metrics should expose lag, drops, retries, and saturation. During an incident, preserving the platform's availability may require transparently dropping or sampling data. Discuss backpressure, queue growth, retries, duplicates, ordering, overload, tenant isolation, durable buffering, load shedding, observability, and the trade-off between availability and data completeness. Question 13. How would you implement safe progressive delivery for an SRE-owned change? I would release to a small, representative cohort first, using a feature flag or canary deployment. Automated checks would compare error rate, latency, saturation, and business or ingestion SLIs against a control group. I would define rollback thresholds before deployment, keep the change reversible, and expand gradually across tenants or regions. A canary is valuable only when telemetry is trustworthy. Otherwise, gradual exposure can merely spread an undetected failure. Be sure to cover canaries, feature flags, automated health checks, comparable cohorts, rollback triggers, blast radius control, observability, and progressive expansion based on slow evidence. Question 14. How do you decide whether to automate an operational task? I prioritize repetitive, well-understood tasks with meaningful toil and low ambiguity, such as standard remediation or capacity adjustments. Before automating, I document the manual procedure, define safety checks, limit permissions, make actions reversible, and add audit logging. I test failure paths and include a kill switch. Automation should reduce cognitive load, not hide risk, so actions involving uncertain diagnosis or large blast radius may still require human approval. Explain frequency, risk, toil, determinism, reversibility, existing runbooks, testing, permissions, observability, and when human judgment should remain part of the process. Question 15. How would you investigate and reduce recurring toil for an SRE team? I would measure on-call interruptions by service, symptom, duration, and recurrence, then separate genuine engineering work from avoidable manual operations. Recurring dashboard fixes might indicate poor defaults, missing automation, or an unreliable dependency. I would prioritize improvements using frequency and customer impact, create self-service tooling where appropriate, and track toil after each change. The success metric is not automation count. It is fewer interruptions and more time for planned reliability work. Mention measuring interruption volume, categorizing work, identifying root causes, prioritizing by impact, improving self-service, automating safely, and tracking whether toil reduction creates sustainable capacity. Question 16. What would you include in a blameless postmortem after an observability outage? I would document the impact, detection time, timeline, relevant signals, decisions, mitigations, and recovery evidence. The analysis should examine system design, deployment processes, alert gaps, and organizational conditions rather than assign personal blame. Actions need to be specific, prioritized, measurable, and owned, such as improving a failover test or changing a deployment guardrail. I would share the findings broadly and revisit actions later to confirm they actually reduced recurrence risk. Focus on factual timeline, customer impact, detection, contributing conditions, response decisions, recovery, systemic causes, prioritized corrective actions, owners, deadlines, and learning without individual blame. Question 17. How would you secure an SRE-operated observability platform? I would apply least privilege to services and operators, isolate tenants, encrypt data in transit and at rest, and manage credentials through a dedicated secrets system. Authentication and authorization should be centralized, with strong audit trails for administrative actions. I would restrict network paths, patch dependencies, and scan images and infrastructure. Break glass access can support incidents, but it needs time limits, approval or logging, and post-incident review. Cover least privilege, tenant isolation, encryption, secrets management, authentication, authorization, audit trails, network controls, vulnerability management, safe debugging, and balancing access with incident response speed. Question 18. How would you test the reliability of a service before and after launch? Before launch, I would combine functional tests with load, stress, soak, and dependency failure tests. I would verify latency percentiles, queue behavior, resource limits, recovery procedures, and alert correctness under realistic traffic. After launch, a canary provides production evidence before broad rollout. Controlled fault injection can test zone loss, slow dependencies, and malformed data. Every exercise should produce a measured result and a follow-up improvement, not merely a pass or fail. Discuss unit and integration tests, load and stress testing, failure injection, dependency simulation, recovery drills, canary validation, performance baselines, and converting discovered weaknesses into operational controls. Question 19. A dashboard query suddenly causes excessive backend load. What would you do? I would first protect shared capacity by applying query limits, throttling, or temporarily disabling the offending path if necessary. Then I would inspect query duration, range, resolution, concurrency, cardinality, and cache behavior, comparing the change with recent deployments or tenant activity. I would optimize recording rules, indexing, aggregation, or dashboard refresh intervals where appropriate. I would communicate any temporary limits clearly and use post-incident analysis to prevent repeat overload. Explain protecting the platform, examining query shape and concurrency, identifying expensive labels or ranges, applying limits and caching, communicating impact, and preserving useful customer functionality during mitigation. Question 20. How would you balance reliability, feature delivery, and open-source community needs at Grafana? I would make the trade-off explicit through SLOs and error budgets rather than treating reliability as an unlimited constraint. If a service is healthy, the team can deliver iteratively. If the budget is exhausted, reliability work takes priority. For open-source components, I would consider compatibility, upgrade paths, documentation, and upstream collaboration, not just internal fixes. Staged releases and clear communication let us move quickly while protecting customers and sustaining community trust. In your answer, connect error budgets, customer impact, transparent trade-offs, compatibility, upstream collaboration, maintainability, staged delivery, and investment in reliability as a product capability. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.